Have you noticed how a lot of ships have this strange protrusion at the forward end? It's a big lump of metal sticking out below the water, and we call it the bulbous bow. But it serves a specific purpose. In this video I'm going to tell you what it is for and why they are fitted. Looking at these different pictures, you can see the ships are all different sizes. And just like the ships, the bulbous bows are also all different sizes. They're all designed specifically for the ship in which they are fitted, and they're all designed to serve one main function. To understand a bulb, let's first consider this vessel which does not have a bulb fitted. As it moves through the water, a pressure wave builds up at the front of the ship. This increases the height of the water. The ship is pushing it ahead, but that water has to go somewhere. So what happens? It flows back down the side of the hull. It will keep flowing back down, forming this wave all the way along the side of the hull. Now the problem with this is it increases the drag of the vessel. It's in contact with a larger surface area of water, it's coming higher up the hull, the water is moving at an inconsistent speed because it's going up and down as well as along. This increases the fuel consumption of the vessel. We need to find a way to mitigate this wave. We can model this wave mathematically. On this graph I've plotted a curve of y equals sine x. If we think back to mathematics, we also know if we plot another curve that is 180 degrees out of phase with our initial curve, then they will actually cancel each other out. All you do is you add up each of the points along the curve, and the resultant is this line straight through the middle. If we could generate the same thing on a ship, we would be able to mitigate that wave that's causing all that drag. Let's now return to our original ship diagram. I've now taken her out of the water so you can see the shape of the hull underneath. If we zoom in on the bow area, because that's the area we're interested in, I can do a quick redesign and add a bulb and change the underwater shape. This is going to affect the way the water moves around the hull. If we think back to the original waveform, I can overlay it here in blue. This is the effect that the hull itself has on the water flowing around it. But we've now got this additional bulb at the front. So what I can do is I can overlay the waves generated by that bulb alone, and I'm going to put them here in red. Now you'll notice that these two waves are out of phase with each other. And for what we just went through with the maths, we know that those waves can cancel each other out if they're out of phase the correct amount. In this case they are. And what that does is that flattens out the waterline along the full length of the hull. It does mean you still get that slight uprise here at the bow, but along the majority of the length, the water is now flat. This has reduced the drag and it's reduced the fuel consumption. And this is the main reason for fitting a bulb. If we remember back to the start of the video, we saw that old bulbs are different. They're designed specifically to produce that wave 180 degrees out of phase to reduce the fuel consumption on their designed vessel. Anything outside of the design parameters, we're talking speed, loading conditions, hull size, the bulb will no longer work, and it would actually increase fuel consumption because it's an extra lump of metal that the ship is having to carry around. If it doesn't produce that useful wave, it's no longer any good. And that brings us to the end of today's video. Hopefully you found the information useful. Until next time, thank you for watching and goodbye.